Consider this electrical circuit. 3 resistors, 6 ohms, 14 ohms, and 29 ohms, are connected in parallel. What is the equivalent resistance of this combination of resistors? And what is the total current that's coming from a 12-volt battery? Now, normally I would write down a little list of what is given. But in electrical circuits, all this is best done in an actual electrical diagram. So let's draw this electrical diagram right here. We have a 12-volt battery, so we know we have a voltage source, an EMF, electromotive force source, and it is 12 volts. And this is the positive side. The long stem is the positive side, and the short stem is the negative. And these are leads or copper wires. And we'll have a resistance, 3 of them, 6 ohms, 14, and 29, and they're connected in parallel. By parallel, we mean just that, parallel, just like you would do in mathematics. Here's something that is in parallel. Here is another resistance in parallel. Just like geometry, these 3 items are in parallel. So we're going to connect them up to the circuit. And there we have a parallel circuit. Going to give each one here a value. It doesn't matter what order we're going to put them in for our purposes. So let's go in this order right here. So this one has a resistance of 6 ohms and 14 ohms and 29 ohms. And this symbol here, that's omega. It's the last Greek letter of the alphabet, the last letter in the Greek alphabet, omega. And it's pronounced ohm, after George Ohm. Value of resistance. And the first thing we need to do is find an equivalent resistance. Find equivalent resistance. It says here, what is the equivalent resistance of this combination? Find the equivalent resistance. And I'll write down R EQ. Let's find the equivalent resistance. Have a look at our equations. And equation 42 is with reference to resistors that are in a series. And we want resistors that are in parallel. And the equation for resistance that are in parallel, 1 over the equivalent resistance is equal to 1 over the first resistance plus 1 over the second plus 1 over the third, etc. There is this other equation here for equivalent resistance, but this is only with reference to 2 resistors that are in parallel with each other. When you have more than 2, 3 or more, then we'll need to use this equation. So we have 3 right now, so we're going to be using this one. And the equation is 1 over the equivalent resistance is equal to 1 over the first resistors plus 1 over the second one plus 1 over the third one plus 1 over the fourth one, etc. We only have 3. Putting in the numbers now. 1 divided by the equivalent resistance is equal to 1 divided by the first resistance, which is 6 ohms, plus 1 over 14 ohms, plus 1 over 29 ohms. Now we can change these into decimal forms. We'll go ahead and do that in our calculators. So 1 divided by the equivalent resistance, which we're looking for, is equal to 1 divided by 6, 0.16667 repeated ohms, plus 1 divided by 14 is equal to 0.07143 ohms, plus 1 divided by 29, 0.03448 ohms. Or you can put all of these in your calculator, following the proper rules of BEDMAS, and do that addition. So doing this addition here, you got to keep in mind that once you do this addition, it is not the end of finding the equivalent resistance. We have one more step to do. So adding all of these up, the answer is 0.27258 ohms. But the equivalent resistance we're looking for is here in the denominator. So we need to multiply, we need to bring this to the numerator. So we're going to multiply both sides by Req. Doing that, we'll get 1 is equal to, multiplying both sides by Req is equal to 0.27258 ohms resistance equivalent. We want to isolate R. Therefore, dividing both sides by this value. Dividing both sides, it looks like this. 1 divided by 0.27258 ohms is equal to the equivalent resistance. That's a decimal point. Doing this division now, equivalent resistance will be 3.67 ohms. So now we can redraw this circuit with just one resistance, replacing all of these three with just one. And that becomes a series circuit. And it would look like this. Here's our voltage source, 12 volts. And this now is 3.67 ohms. This is the equivalent resistance of all of these. And we have 12 volts. And part 2 of this is, what is the total current from the battery? So we need to find current. And current, by convention, current is going to flow out of the positive terminal of the battery. Current has the symbol I, and we want to find the total current. We have all we need right here to apply Ohm's law. Voltage equals IR. That's Ohm's law. And current is what we want to find, so divide both sides by R. Voltage divided by resistance then is equal to the current. And this, in this particular case, the current is going to be the total current that is being drawn here. Putting in the values, you have 12 volts divided by, this will be the equivalent resistance, 3.67 ohms, is equal to the total current. And 12 divided by 3.67 ohms is equal to 3.27, and the unit is going to be amps. Voltage divided by ohms will give us amps. That is the proper unit for current. Or it can be written current total is equal to 3.27, letter A for amps. And that is the current being drawn here. 3.27 amps. Back to our question. It says, what is the total current from the 12-volt battery? We have just solved that.